Hello everyone and welcome back to the channel. In system design, getting information from one service to another, especially when something important happens, is critical. We have talked about APIs where you ask for data, but what if you want a system to tell you when something happens instantly without you constantly asking? This is where webhooks come into play. In system design interviews, discussing webhooks demonstrates a powerful understanding of asynchronous, event-driven integration. Today, we are diving into what webhooks are, why they are so effective, and their role in modern system design. So let's first understand the problem webhook solves. Imagine you are building a system that needs to know immediately when a payment is completed in a third-party payment gateway like Stripe. Let's have our pen. So here we have Stripe, that's for the S, and we have our application. That's okay, let's remove this. And we have here our app. Okay. So the traditional way, it would be pulling. Basically, our app would repeatedly send requests to Stripe's API every few seconds or minutes, asking, is the payment done yet? Is it done yet? Is it done yet? Something like that. So it will ask a question, is it done yet? Stripe will say no. It will send again, is it done yet? Stripe will say no. Is it done yet? It will say no. Is it done yet? Yes, it's done. This is incredibly inefficient. It consumes your system resources, Stripe resources, and creates unnecessary network traffic. All for possibly no new information. It also introduces latency. You only find out about the event after your next pull. Webhooks offer a much more elegant solution by enabling push paged notification. Okay, so what are webhooks? What exactly is a webhook? A webhook is essentially a user-defined HTTP callback that is triggered by a specific event in a source system. Think of it like a reverse API or an automated phone call. And instead of your system calling an API to pull data, the source system, which is Stripe for this example, calls a URL that you provide to it, which is your webhook URL, whenever a designed event occurs. When that event happens, the source system makes an HTTP request, usually a POST request, to your specific webhook URL, sending along a payload of data about the event. It's a powerful way for systems to automatically notify each other about important things happen. So on high level, we will have our app again. And we have here Stripe. So we don't have to use polling. We don't have to send a lot of events to know if we have a new data or something. Whenever something happens in Stripe has a callback URL. It will send a notification to our app. It's pretty simple. It's pretty easy. Okay. I'll just talk about high level. Right now we will just take one step. We'll try to understand, we will trace the typical flow of how webhooks operate. So again, we have our app here. And here we have Stripe. First, we have setup and registration. The destination system, which is your application here, will generate or provides a unique webhook URL. This URL is then registered within the source system, which would be the sender and Stripe here in our example, telling it sends a notification to this event, to this URL You might also specify which events you are interested in. For example, we will say send us a notification when any payment succeeds. And after that, we have event trigger. Like an event occurs in the system, in the source system. For instance, a customer successfully complete a payment on Stripe. We will go to the next step, which will be an HTTP post request. The source system, which is Stripe here, will make an HTTP post request to your registered webhook URL. And in this request, we will have a payload. The body of this post request contains a payload of data, usually in a JSON format, detailing the event that just happened. For example, transaction ID, amount, customer details, etc. And number 5, we have the destination acknowledgement. Like your destination system received this post request. It's crucial that your system process this request quickly and returns an HTTP 200, or 200, 201, or any HTTP status code that starts with 2. To the sender. This tells the sender, I received your notification successfully, and then we will do something with it. Okay, and lastly, we have asynchronous processing. After acknowledge the system or the server or the recipient or the receipt, which is your destination system, typically process the event's payload asynchronously. This usually means parsing the data and pushing it into a message queue like Kafka or RabbitMQ for background workers to handle the actual business logic, ensuring your webhook endpoints remains fast and responsive. Okay, why webhooks matter in system design? Webhooks are critical in system design for several compiling reasons. Number 1, real-time or near real-time notifications. They provide significantly faster event notification than polling, enabling truly real-time updates and integration. Number 2, reduced load efficiency. They eliminate the wasteful polling requests for both the sender, who doesn't need to respond to constant polls, and the receiver, who doesn't need to constantly ask. This makes both systems more effective or efficient. Number 3, decoupling. Webhooks promotes loose coupling between systems. The sender doesn't need to acknowledge anything about the receiver internal logic, only the event type and URL to call. The receiver just needs to know how to deal with the payload. And number 5, event-driven architecture. They are the fundamental building block for designing reactive event-driven architectures where services react to events as they happen rather than constantly checking for changes. Number 6, scalability. The sender's responsibility is just to send an HTTP request. The receiver can scale its webhook endpoint and its asynchronous processing pipeline independently to handle process of incoming events. Lastly, common for integrations. Webhooks are the backbone of integrations with many popular SaaS platforms like payment gateways, CRM systems, version control platforms like GitHub, and communication tools. Okay, it's not great all the time. While it's powerful, webhooks introduce their own set of design challenges. Number 1, reliability. What if your destination system, which is a receiver, is temporarily down or slow when the webhook is sent? The sender needs a robust retry mechanism with, and often a dead letter queue for failed delivers. Number 2, security. Anyone could theoretically send a post request to your webhook URL. You need to verify the sender. This is typically done using webhook signature. The sender signs the payload with a secret key, and you verify the signature. Always use HTTPS. Number 3, idempotency. Again, this one is big. Your webhook endpoint must be idempotent. An event might be delivered multiple times due to retries. Your system must process a duplicate event gracefully without side effects, processing the same payment twice, for example. Number 4. Your webhook endpoints needs to be highly available and scalable to handle bursts of incoming events without becoming bottlenecks. Pushing to to a queue for asynchronous processing is a key here. Okay, you need to think about that. So that's it for this video. Webhooks are a vital component in modern system design, enabling real-time, efficient, and decoupled communication between services by understanding their push-based nature, their implement flow, and critically how to handle reliable security and idempotency. So that's it for this video, and see you in the future, guys.